Hello everyone. Thank you for coming to the meet. Today we were supposed to showcase some of our tools that we have launched recently, the likes of Ingenuity Draft, the case study, Foundation Lab, and Fluidflow Lab, also traffic simulation. You'll be able to see us walk you through the applications and how to use them and how to apply them in your daily lives. Now, John Michael, the CEO and founder of Engineering Hub. I'm going to give Owen Richard the opportunity to introduce himself.
Good evening, everyone. My name is Owen Richard, co-founder and Business and Strategy Engineering Hub. Welcome to the meet, and I hope we'll have a fruitful evening. Okay.
Okay, good. The first person who is going to take us through the showcase will be Moses Riro. Moses Riro is a team member on marketing. He'll introduce himself better. He's going to take us through Ingenuity Draft and maybe some bits of the case study. Okay, Moses Riro. Okay.
Okay, hello guys, and welcome all to the meet, and it's nice to have you all guys here. Yeah, my name is Moses Riro, and I'm the marketing director, Engineering Hub. And today I will be showcasing some few improvement in Engineering Hub, especially in Ingenuity and the case study. Hope you guys have interacted with Ingenuity and the case study. So I will first briefly take like 5 minutes, take you through the CaseForge AI. Then I will come later, then take you through the Ingenuity drafts. So before I do anything, I would like Michael maybe to introduce maybe other people in the meet so that we can know who we are talking to. You can see we are not, yeah. For example, like anyone like Elizabeth Nyakoa or David KN, you guys can say hi so that we know who we are talking to. In the meantime, as I try to share my screen, you guys can introduce yourself.
Hello.
Yes, we can hear you, David.
Oh, my name is David Kilonzo. I'm a mechanical engineer.
Okay, thank you, David, for having you. Maybe Elizabeth, you can say hi.
Hi, my name is Elizabeth Nyakoa from Civil Engineering.
Okay, thank you, Elizabeth. And yeah, I think that is enough. And we are happy to have you all. Those people have represented you. We value you so much. So I'll go ahead and share my screen and show you. Yeah, hope you guys can see my screen. Yeah, so I will briefly take you through the case for the AI first. As you all know, I hope everyone here knows how to access Engineering Hub from any website or any search engine. You can search Engineering Hub, then you can just access it. If you don't have an account, make sure you create an account to experience the tools we have. You'll keep me in touch to make sure that my screen is always on. So I'm going to take you through the case for AI. As you can see, nowadays we have upgraded. If you want premium services, you can always pay. But if you are not ready to pay, you can still use the free plan. So I'm going to show you how the case study works. So these are some of the things that we have. I think I'm having trouble with my
Hello, apologies to everyone. I think Riro has troubles with his laptop, so I'm going to take over and try and explain the tools. Now, let me share my screen. For Ingenuity, you can, let me sign in. Yeah, so this is Ingenuity. Basically, it is just say a chatbot, but it's not really a chatbot because it's an improved version. Say if I wanted to start a conversation, you'll be able to see we have about 7 specialized solvers that ensure that whatever you get is a more accurate output than the rest of the generic AIs that we have out here. That is the main purpose of Ingenuity. Now, what we added that I wanted to showcase, this part of Ingenuity has been known to you guys for quite a long time, is the draft. Now, the draft brings drafting to the web. You can draft and with the help of an AI. As you can see, now, for the drafting canvas, it supports, you can come up with anything. It supports a line, rectangles, circles, as you can see, avocado, the ellipse, arc center, polyline, spline, revision cloud, point marker, slot. So for people who have interacted with softwares like AutoCAD, ArchiCAD, you'll be able to identify the tools that are on this other side. So let us try and draw something or draft something rather. Okay. I don't know. What do you want us to draft? We can. This is the line tool in action. Okay, then let us try the rectangle tool. Then we can try the circle. Now, with this, you can come up with anything you want to draw. You can draw a column, you can draw something, a mechanical tool, anything that you want to draw. Now, we are going to test the AI on this other side. Now, another thing, you can select a tool like this, and then you come to the props on this other side, and under the props, you'll get the rectangle properties. Props just means properties, and you can change. You can change the color. You can do a hatch fill for the triangle. For the rectangle, sorry. And then use, as you can see,
Jovan,
we have diagonal lines.
Michael, just a minute.
You can do a cross hatch.
Michael, just a minute.
Or some dots, or just concrete. Yeah, so, and you can change the spacing, everything. So this is the props. And then you can draw based on layers. Now, whatever I've drawn, they were drawn under the default layer. Now you can switch to the construction layer. And then you draw something. Say, let me draw this now. Under construction layer. And then I can come and hide the default layer. And now they are hidden. So I have the construction layer only being shown. Now I make the default layer visible and they are back, and then I can make the construction layer hidden, and then you have your default layer now. Now let us try the AI. We are going to draw, say, just draw a column and label. That is okay. Now, as it does that, you can save your projects. Here you can change the name for the project. Okay. You can create another. You can create another drawing tab. You can open is just you can open a JSON drawing file. Now, you can also export as a DXF, as a PDF. We'll be seeing that just in just a minute. Let the AI do something. So this is Ingenuity Draft. Basically, you can draft on the web right now with the help of AI. So it's quicker, it's faster, and I can say it's smarter because whatever you've drawn on the canvas, the AI has context of it. Now you can see if I toggled this share canvas view, the AI and ask a question rather than telling it to draw. It would have told me, say I drew a column here. It can analyze the column based on the information that you've filled on it. Say you drew a mechanical tool, anything. It can analyze with you and tell you what you've drawn on the canvas. So yeah, the AI has canvas context and it can also draw. Now, for export as a PDF, when you click export as a PDF, you just come here, you can write your project name, say John. I don't know if you can see, drawn by John, checked by John. Yeah. So you can upload as a logo. Let us upload a logo, which will be basically a tool. Now, when I click export as PDF, you can come and we can check what has been removed, what has been exported as a PDF. Now you'll see that the logo is here, project title, and every other thing, and the drawing that we had has been exported. So basically, that is Ingenuity Draft for you. Now, moving on, we are going to showcase the case. Okay, I'm going to give Owen Richard a chance to present the Trust Lab as I prepare for the case study. Owen?
Thank you, Michael. Now let me share my screen. Just a minute. Okay, so the quickest way to access the Trust Lab is to head over to Engineering Hub by typing in engineeringhub.engineer on your search engine. Then you head over to the learning part and click on design materials. Then scroll downwards to the truss analysis tool. Now, apart from reinforced concrete and steel, the other most common aspect of building is truss and frames, which are very difficult to analyze and visualize. So the concept idea came about when we were designing a modular bridge that was supposed to showcase the real picture of a standard bridge in Philadelphia. So the concept was that the time that it takes to analyze and to come up with the frames and trusses is a lot of time. And so we decided to include Truss Lab in our ecosystem, basically enabling us to modify, visualize, and analyze, carry out the whole analysis of frames and Truss Labs. So I'm going to sketch, so from the props here, as you can see on the lead head, there's the selection tool, there's the node tool, there's the line, the member tool, then there's the load tool, and there's the support tool. So I'm going to sketch a simple illustration of a truss and a frame so that you can see the visualization and the interpretation and the analysis on the Truss Lab platform. So before I begin drawing, you can zoom in and zoom out on the canvas. Each box is about 50 mm, enabling a quick draw and a quick analysis and a quick study. So the first thing you'll do is to create the nodes. So let me create a 4-member node of 200 mm because one box is roughly 50. After creating the 4 nodes, I'll connect them with the member tool. The easier feature you can see is that it denotes the naming by following the process. You know that the supports can exist in majorly 4 ways. They can be fixed, they can be pinned, and they can be roller supports. So to cater for this, you'll select the support and change. If you want a roller support, a fixed support, and also. So I'll use a roller support and a pinned support. Then I'll add my load. In analysis of trusses, we know that loads are added to the nodes, helping in calculation. So I'll apply the load. From the load, you can specify if it is a wind load, a live load, a wind load from the side, a live load from the top sides, and the seismic loads. So I'll use the dead load in my analysis. Let us change the direction of the loading. So I'll use add. So now you can see the load, and because a triangular member is a triangular system is not a stable system, we'll add. After adding the diagonal members, we have basically created a basic form of a truss. And after doing that, you can click on Analyze. Now, from the output, you can see that it is capable of notifying the number of members, the number of reactions, the number of joins, and proving if the structure is determinate or indeterminate. The status is indeterminate. You can see the maximum tension, the maximum compression, the member utilization, member 4. Member 4 from the naming says this member, where the loading is applied, compression member. And you can see the internal force diagrams. So you can also see the deflection from the diagram. You can see the deflection. You can visualize the analysis of the deflection, how it will bend and how it will react depending on the supports, which is the roller support and the pin support, and the loading from the node 3. You can remove the tags to have a clean output. Yeah, so that is basically a simple model of a truss. And to help with this, we have templates of all the major trusses that exist. This is a Pratt truss, a Howe truss, a Warren truss, and Warrens with verticals. You can also have a 3D optimization for this and view the members. So the next thing is we'll utilize the templates and see the analysis for this. So another thing I didn't mention is that it uses basically all the forms of analysis of trusses to analyze the members. So it uses a method of joints, method of sections, and matrix method. And from this, you can see from the output, you can see. So the only thing remaining is I'm encouraging you to go and test it out after this, and you'll see. So this is a Howe truss with declining members on the opposite side. You can see that 3D visualization. In your analysis, if you want to analyze it, you can head over to the 2D. And from this, you can see, if you want to change the supports, we'll just toggle on the support and change it out. Another thing we have is the frames. So you can see. Yeah, so from that you can see that it can analyze trusses and frames in a quick and a visual way. So thank you, and check it out. So I'll explain the process of getting to the truss lab again, so that you can practice with it, test it out, and see the results. Give us the feedback on this, because your output, your feedback is what enables us create a better platform that we can utilize in our engineering practices. So thank you. Michael, back to you. You can showcase the truss. Yeah. So I've said that I'll okay, there's a hand, David Saitot. David?
Oh, hello. I have a question.
Yes.
Okay, you have said you can only apply the loads at the node. So how about a UDL? And then the second question is about the analysis. I saw you can add these different types of loads, like the winds and the seismic kind of loadings. So is it something that are based on maybe does it follow maybe a specific design standard, or let's say, a reference like maybe Eurocode or American Standard, or how does it work?
Okay, so thank you, David, for the question. So all our features on Engineering Hub follow the basic codes that we use in Kenya. That is the British Standard, and another code is the Eurocode. But for this, we utilize the British, the BS code. Yeah, and for the loads, you can add any type of load. The only thing remaining is you trying it out and giving us your thumbs up. Okay, David?
Okay, thank you. How about the UDL?
Yeah, you can add the UDL. Let me just a minute. You can add the UDL, but you know that in analysis of trusses, even if there's a UDL, we first need to convert the UDL to a point load. Then using the point load, so that is why we have utilized the point load. So the UDL is, in that concept, basically a point load, okay? When you utilize the method of joints.
Okay, thank you, Owen. For the UDL, you can just click on the load tool there, and then you'll be able to add either a UDL or a point load. So first of all, you select a member on the task. Like when you want to add a load, you click on a node. So you click on a member, and then when you click on add load, it will show UDL as an option for a load that can be added, because basically you cannot add a UDL on a point or on a node. I hope that answers David. You can just test it out, it's there. Now I'm going to invite Elbethel to walk us through the column tool, column design tool. Elbethel.
Thank you, John. I'm Elbethel, and I currently serve as the Chief Corporate Outreach Officer for Engineering Hub. So I'm going to display how the column design tool works in Engineering Hub. So allow me to present my screen. And in case, so I hope I'm audible enough. So I'm going to showcase the column design tool. And the column design tool, in case by any chance you don't know how to get it, once you log into Engineering Hub, you can just search here for the column and find the column design tool here. Just a minute. Yeah. So I've had the previous person ask a question on which standards you use. So there is Eurocode and there is BS 8110 and Eurocode 2. So our column design tool allows us to do two things. You can either check a given section or you can design a given section. So you'll start with, I think you should start with the design. It's easy. So columns have given lengths, and you have the effective lengths depending on the support conditions. So assuming our effective length of the column we're going to design is 3000 millimeters as shown, and the section is a rectangle, we can then assume a width and depth of 200 millimeters. Check if the load will pass. And then you can assume an axial load of 500 millimeters, and this concrete grade steel grade of 460. We can assume the moment to be this as it is here. It's more than the minimum. And then you can assume, you then specify the main bar, the minimum main bar you prefer, and the links. The links also serve as the stirrups to resist against shear. You specify the minimum number of bars along the X direction and along the Y direction. Now you have specified 2. If they are enough, the system will give us 2. And if they are not enough, the system will give us more. So our cover is specified as 30 millimeters. Yeah. We have allowed the sections to vary. Let's try not to allow. Okay, let's allow by 10 millimeters. And this one, let's put it 300. 300. This will be our maximum width and maximum height. Then this one, put at them at a maximum of 3 and 3. Now, if we run the auto design, we find that our design, this is now the result of our design. Engineering Hub has auto designed for us. Now you see that our design passes in axial, in terms of axial moments along the x-axis, moments along the y-axis, and the biaxial moments. They have all satisfied the design. These percentages here mean our column capacity is loaded axially to a capacity of 34%, meaning the load, it will carry more. We are just currently at 34% of its capacity. And this is the same 62, 62, 97. The dimensions for our column are 200 millimeters by 270 millimeters. And now these are the results of our design. 200 millimeters by 270 millimeters, the width and the depth, LX and LY, radius of gyration, effective depth, cover, capacity, and the likes. Our concrete strength is 30. These are more informations. We will use 4025 for this. Yeah, we will use 4025. And the total area per by this one. Total steel area is 1963 millimeters. It has passed the check of minimum clear spacing. Yeah, so it has done all these checks and it has given us our results. It has given us the slenderness in the X direction and the Y direction. The column is not a long column, so it's a short column since it's not slender. Yeah. So it has checked all a given section. Load doesn't change. The concrete grade and steel grade doesn't change. And then for the main bar, you can use 16. Yeah, then you can check the design. Now you see we have reduced the main bar to 16. It has failed since the design is inadequate. And we reduced the total size from 200 by 200, 200 by 270 to 200 by 200. So checking that, we find that it fails. And as an engineer, once something fails in a calculation, you first try to figure out where it failed from. So you see, the problem is our moments. Yeah, the problem is our moments. There are a lot compared with the design. Now, in such a case, you are designing and your design phase, you now start to look for columns. What's limiting us is usually the area of steel, the area of concrete, the grade of concrete, the grade of steel used. Now, for us, we can change the grade of steel, but we can change the area of concrete. For our case, we can change now this one to be 300 by 300. And if we check the design, yeah, now when you change to 300 by 300, the design is adequate, despite using the same reinforcements, which is 4016. I've just added the area. So times our designs can fail, but if you use Engineering Hub, the iteration will take a shorter time than necessary. And like manual calculations, where we needed to start a new page, rewrite all the calculations, all the formulas. Now, we introduce Engineering Hub. I'm efficient for that. Is there any question? Ronnie, please switch off. Yeah, is there any question?
Okay, thank you. Alberto.
You're welcome.
Now, on the next phase, I'll be showcasing the traffic analysis tool. Now, this is one of our flagship tools. Just let me share my screen. Okay. Yeah, this is the Traffic Simulation Lab by Engineering Hub. Now, when you come to the Traffic Simulation Lab, what you're going to find, basically, is just one, you can get something playful, is the simulation. The simulation is just playful. And then you can get a HCM engineering analysis if you want to do some engineering stuff. Now I'm going to play the simulation. So what we have here is basically like a dashboard. On your left side, on my left side, you'll get the controls. Here you can build a network. Now you have an AI generator to help you build the network, but you can also build a network by yourself. One, there is an OpenStreetMap import so that you can import real road networks. There's a node and a junction and a signal to help you create networks like these. There are templates. These are pre-designed templates by us so that you can visualize whatever is going on quite easily. And then we have parameters here, like we can change the weather from clear to rain to fog to night. And this reduces speed by either 15% for rain, 30% for fog, etc. You can change the flow and the speed of the vehicles, and you can change the percentage of trucks, the gap behavior, the headway, etc. Now I'm going to, and on the right side, we have the analysis. Now the analysis, the first thing that it normally shows is just the level of service, the average speed, and this, but you